Welcome to a new video lecture. Today we will discuss a problem related with the maximum shear force and maximum bending moment when a train of constant load traveling across a beam. So please note down the question. A train of concentrated loads as shown in the figure moves from left to right on a simply supported girder of span 16 meters. Determine the absolute maximum shear force and bending moment developed in the beam. Okay. So in the given question, a simply supported beam with a 16 meter span is given, and a series of loads, the loads is 40 kilonewton is leading, and then behind 80 kilonewton, then 60 kilonewton and 20 kilonewton, and the distance between each load is also given. So firstly, we note down that the positive shear force will occur at the support A. So we have to place the load in this format. In the first case, we will place the 20 kilonewton over the support A. Then we will find out the positive shear force value at A. So we can easily find out if we place this 20 kilonewton over the point support A, the ordinate, maximum ordinate will be 1. And if you can use similar triangle law, you can easily find out the remaining ordinates also. Means this ordinate you can calculate it by the total distance is 16. So if you subtract 3 from that 16, you will get 13 by 16. Remaining, you can find out 16 minus the 5, then 11 by 16. And after that, 7. 16 minus 7, you will get 9 by 16. Then you can directly apply 20 multiplied by 1, then 60 multiplied by 13 by 16, then 80 multiplied by 11 by 16, then last one 40 multiplied by 9 by 16. And if you sum up all those values, you will finally get 146.25 kilonewton. Okay, this is first condition. Then you have to apply the 60 kilonewton over the point A. Okay, then you calculate the ordinate correspondingly, and you have to multiply the corresponding ordinate, and finally you will get 160 kilonewton. And this value is more when compared with this 146.25 when this 20 kilonewton is acting at the support A. Again, you can choose the third case when 80 kilonewton is placed over the support A. Then what is the shear force value? It is also again reducing 150 kilonewton. The last one more case is there. If you put the value 40 here, then you will get the value of 40 again decreasing. So the maximum positive value is 160 kilonewton when 60 kilonewton is placed at the support A. Okay, then coming to the next one, negative shear force value. The negative shear force value will only occur at the support B. Okay, the ordinate, if we have to place the load in this format, that means 40 kilonewton to be placed at the support B, then 80 will be behind, then 60 and 20. Then you have to calculate the ordinate values by using similar triangle law. The total distance is 16, and then you have to subtract this 2, then you will get 14 by 16. Then you have to subtract this 4 from 16, 12 by 16. Then you have to subtract 7, 9 by 16. And if you multiply directly, you will get the value of 166.25 kilonewton. Then you have to consider the second case, means you have to put the 80 kilonewton over the support to B. Then you have to, then after using the similar triangle law, you will get the values 14 by 16 and 11 by 16. And if you substitute the value, you will finally get 146.25 kilonewton. The value is decreasing. You only check out the numerical value. Okay. Then you can consider the third case, that is 60 kilonewton to be placed over the support B. Then you will get 76.25. Then you can also apply the last case, the value again will decrease. So in this case, the maximum negative shear force value is going to be 166.25 kilonewton. Okay. So in this way, we will calculate the maximum shear force when a train of constant load traveling across a beam. Now we will find the absolute maximum bending moment in the beam. So first of all, we have to calculate the resultant load, means you have to sum all the loads given. means 20 plus 60 plus 80 plus 40, giving the value as 200. So next our step is to find out what is the position of this resultant in the given series, where it is going to occur. So we are going to take the position B, the distance from the end point to this one is x. Let us take the distance be x, and taking the moment about the point is this 40 kilonewton acting. So you will get the value as 2.7. You are just going to take the moment about this point. Okay. So this is the value 2.7. The resultant is acting at a distance of 2.7 from this point, or from this 40 kilonewton load acting. So after that you have to analyze the losses. It is nearer to this 80 and this 60. Okay. Then you have to check out the resultant is very closer to which load. In this case, the distance between 80 kilonewton and the resultant is 0.7, and 60 and the resultant is 1.3. So the bending moment will occur under the 80 kilonewton. Since the resultant and this 80 kilonewton distance is very closer, that is the one of the guidelines. Okay. So our next intention is to find out the distance of 80 kilonewton from the supported. Where to place this 80 kilonewton? Okay, in this 60 meter beam, where to place this 80 kilonewton? For finding out, we will use our formula L by 2 plus D by 2. L by 2 means the span to be, or 16 by 2 at the mid span, plus D by 2. D by 2 means the distance between this 80 kilonewton and the resultant. So finally you get 8.35 meter from the supporting. So you have to place the 80 kilonewton at a distance of 8.35 meter from the supporting. After placing, if the value is 8.35, then the remaining distance will be 60 minus 8.35, you will get 7.65 meter. So after placing, you have to find out the y1 ordinate, y2 ordinate, then y3 and y3. Y3 you can find out easily using your formula. Z multiplied by L minus Z by L. You will finally get, if you substitute the value, 3.9923. Okay, that is the y3 value. Then y1, y2, y3 you can easily find out using the similar triangle law. So after that you have to multiply 20 multiplied by y1, 60 multiplied by y2, then 80 multiplied by yc, then 40 multiplied by y3. Substituting the values, you will finally get 651.524 kilonewton meter. Okay, so I hope the section is clear. With this we will wind up today's section. Thank you all.